cardiac physiology or heart physiology today will change. Previously we have cellular physiology. Am I right? Yeah.
Yeah.
Take a look at the picture. I will discuss first brief anatomy of the heart and the cardiac chambers, and we will gradually start cardiac physiology. As you can see in the picture, the heart is actually two parallel palms, one on the left side, one on the right side. The left palm is a high pressure palm, working with high pressure, and provides the blood for the general circulation. The right side is a volume palm and working with low pressure. Each side has two chambers, one in the upper and one in the lower. The upper chamber is called atria. The lower one, ventricle. So we have a high pressure and high volume, both with the same output. In each side, both have the same output. Means the right side has 5 liters per minute at first, the left side with the same output.
How it could be if the there is a high blood pressure.
The pressure is high, but the output is the same. See the pressure in comparison to the left. In right side, the pressure is 1/6. The high pressure inside the left ventricle is 120. Here it is around 25, the highest pressure amount. The lowest pressure amount here is 80 millimeter of mercury. The lowest pressure here at rest is 8 millimeter of mercury. Means the pressure in the left side is 6 times greater than the right. Here is a volume pump. Here, the left side is a pressure pump. The right side is the volume pump. They are working parallelly. The left side provides general circulation. The right side, pulmonary circulation. So two parallel side pumps. We have 2 chambers at each side. Upper chamber, which is called atria, lower chamber, which is called ventricle. The atria and the ventricles are isolated with a fibrous tissue that is called atrioventricular valves. Atrioventricular valves. On the left side, you have a bileaflet valve, which is called mitral valve. Mitral valve. Between atria and the ventricle, we have atrioventricular valves, which are bigger than the semilunar valve. I will discuss them. So on the left side, we have a 2-leaflet valve, which is called mitral. On the right side, a tri-leaflet, which is called tricuspid valve. With the right atrium and right ventricle, you have tricuspid. Between left atrium and left ventricle, you have the mitral valve. At the outlet of the ventricles, you have 2 extra valves. On the left side, we have aortic valve, a 3-leaflet. Normally, aortic valve has 3 leaflets. On the right side, we have pulmonic valve. As you can see in the picture, the vein of the valves are connected to special muscles, skeletal, just like skeletal muscles. I mean striated muscles, which are called papillary muscles via chorda tendini. These are papillary muscles. See? Papillary muscles. On the right side we have 3 papillary muscles. On the left side, 2. We have 2 papillary muscles. Papillary muscles are connected to the veins of the valves by chorda tendini, a special tendon. The papillary muscles during ventricular contraction will contract, and prevents the leaflets of the valves to be bulged into the atria, because inside the ventricle we have a high pressure in comparison to the atria. In the left ventricle we have 100 at rest, 120 millimeter of mercury. Inside the left atria it is around 6 up to 8 millimeter of mercury. In the right side, the high pressure, I mean the high systolic pressure at rest, it is around 25, 28 millimeter of mercury. Here too, up to 3 millimeter of mercury. So during ventricular contraction, in order to prevent backflow of blood, at the same time, when the ventricles are contracting, the papillary muscle will also contract in order to prevent backflow or bulging of the leaflets of the valves into the atria. These are the functions of the papillary muscles. In some rare instances, for example, when we have myocardial infarction or when the papillary muscles are paralyzed or ruptured, the valves are bulged into the atria and you will have cardiac failure, which may lead to death. So this is the papillary muscle function.
The papillary muscles, they contract in distal or systole?
In systole.
So
We have contraction in systole, not in diastole. The diastole is the relaxation of the
do you mean like that the myocardial infarction is like a problem in the valves or in
No. In myocardial infarction, the circulation of the heart itself, which is actually provided by coronary arteries, will be blocked. When there is no blood, then the cell functions will be deteriorated, stop. At that time, the arteries that provides the blood for the papillary muscles will also be blocked. Then they will be paralyzed. And when they are paralyzed, the leaflets of the cusps or the leaflets of the valves are bulged into the atria, and the cardiac cannot empty efficiently, and this is what we call cardiac failure, which can lead to death. The heart is composed of 3 different tissues: atrial, ventricular, and an excitatory conductive tissue. So we have 3 different tissues in the heart: atrial, ventricular, and an excitatory conductive tissue. If you put a sample cardiac muscle under the microscope, you can see this picture. The atrial and ventricular muscles are just like skeletal muscles. Means if you put a sample under the light microscope, you can find dark and light bands under the microscope. That is why we call them striated, just like a skeletal muscle. As you can see, the cells are parallel, sets at each side and alongside to each other. The cardiac muscles are fusiform, means it's a spindle shaped in form, connected to each other longitudinally. Like this. You see? So, they are branching, then connecting to each other. They are actually lies side by side and longitudinally. At the fusion side, there is an anatomical structure that is called intercalated disc. Intercalated disc means this anatomical structure is the fusion connecting compartment. At intercalated disc, we have gap junctions. Gap junctions. What is gap junction?
Channels between muscle cells.
Means the membranes of two adjacent cells connecting to each other via special proteins, which is called connexin. 6 from each membrane. 6 connexins from each membrane connecting to each other to make a pore, a very low resistance pore opening. This opening permits passage of nutrients, ions, and small molecules in both directions. Ions, nutrients, and small molecules from one cell to the other cell. A very low resistance opening. So when electrical currents starts from somewhere in the heart, then it can easily pass through the heart simultaneously. So the cardiac cells are connected to each other via gap junction. But this electrical current will be stopped at fibrous tissue between the atria and the ventricles, the atrioventricular valves. The electrical currents cannot pass from the atrioventricular valves because they are fibrous tissue. They are isolated tissue for the electrical currents. Electrical currents can easily pass from the excitatory conductive system between the atria and the ventricles. We have an excitatory conducting system. Electrical currents cannot pass from the fibrous tissue. So the electrical currents or impulse or action potential starts somewhere from in the atria and pass from the excitatory conducting system to the ventricle. So We have two syncytium in the heart.
So doctor,
Atrial syncytium, ventricular syncytium. Means they function isolatedly at the same time. Atria can function simultaneously, ventricle can function simultaneously. These are called syncytium. Syncytiums.
so they can't go through fibrous muscles, fibrous tissue.
They cannot pass from the fibrous tissue. A special conducting system, which is called His bundle, can convey the electrical currents from the fibrous tissue.
Only that tissue.
Only that, yes.
From atrium to
From the
ventricle.
atrium.
Well, we also have like that in the skeletal muscle. In the previous term, you presented skeletal muscle for us, and we told us that it may happen like action potential in that muscle. So how it could be?
I will discuss it. We have the same system here with some differences, disparities.
Yeah, and the main concern that how it could like the neuron side, right? Can't cross through the fibrous tissue.
So I discussed it. There is a special band of excitatory conductive system that can transfer, that can convey the impulses from the atria to the ventricle. The impulses cannot pass from the fibrous tissue.
So how it's passed in the skeleton?
What's that?
Skeleton muscle.
In a skeletal muscle, we do not have any fibrous tissue inside the muscle. Inside the heart, we have fibrous tissue, which is an isolation for the passage of electrical currents. In the skeletal muscle, we do not have that fibrous tissue. Outside the muscle, skeletal muscle, we have. You see, but inside we do not have any fibrous tissue. So the electrical current. There are some differences I will discuss. Let me continue the discussion. I will explain. So, three different tissues: atrial, ventricular, conductive. Is there any pad here? Mouse pad? There is no mouse pad?
I don't think so.
Maybe numbers work.
Heart is actually located in the mediastinum.
Yeah.
When you open the sternum, the chest, at the midline, you can see this structure. The out part of the heart is actually called pericardium. Pericardium. The pericardium is actually composed of two layers: visceral and parietal layers. Visceral and parietal layers. Between visceral and parietal layers, there is a thin film of pericardial fluid, which is around 50 milliliters. Pericardial fluid. How much is it?
50 milliliters.
Between this, others,
Two layers.
between varietal and visceral.
Visceral.
Between this, we can
Got you.
So, what is the function of pericardial fluid?
Protect the heart
It is just a lubricant.
Yeah, to prevent like
Provide a very smooth motion of the heart inside the nervous system. A very thin film of fluid inside the pericardial space.
because the pumping of the heart is like that.
Yes, I will discuss. Just like that. When you squeeze, for example, the ladies who wash the
Toward
No.
the left to right.
from the yes, hand side and then the right side and left side in the opposite direction. The cardiac cells, which are called myocytes, are running in an 8-figure form. I mean, spirally, especially when they are coming into the apex.
Yeah.
So when they contract, it is just like squeezing the cloth when you are squeezing the cloth when the ladies are washing. Just like that. Ventricular contraction is just means from the base to the apex. So the cardiac myocytes have two alpha helix, one left side running and the other one right side running.
Right.
So we have pericardium at the outer layer, myocardium in the inner layer, and endocardium in the inner layer. 3 layers. Pericardium, myocardium, which are composed of the myocytes,
Myocardium is very
yes, very thick, and the endocardium. Endocardium is the same endothelial layer of the vascular beds that are coming into the heart. Very smooth layer in the inner part of the heart. This endothelium layer actually covers the surface part of the fibrous valve tissues. Very smooth layer of endothelial structure covers the fibrous valvular structure. When the pericardial space is filled with a high amount of fluid, it is called
Personal fluid?
pericardial tamponade or pericardial effusion. Pericardial effusion. When high amounts of fluid are accumulated in the pericardial space, it is called pericardial effusion or tamponade. So in order to remove the pressure from pericardial space over the heart, especially on the right side. On the right side, we have a low pressure, high volume pump. So pericardial space pressure can prevent right side filling and the cardiac output will be dropped. So in order to correct the situation, you should what should you do?
Remove it.
Remove this extra fluid by inserting a tube. Open the pericardium, put in the tube, a drain inside the pericardial space and evacuate that fluid. Otherwise, the right side of the heart cannot fill with blood and cannot efficiently contract. So this is called tamponade or pericardial effusion. Take a look at the vasculature that is coming into and going out the heart. We have two circulation, general and the pulmonary circulation. Let's start from the general circulation. From the left ventricle, a big artery goes off. This is called the aorta. See, take a look. This is ascending arch, descending. Descending is composed of different parts. Thoracic, abdominal, descending, aortic arch. So, in the arch we have most cases, we have three branches. Yes. Brachiocephalic, left condylarthritic, and left subclavian. Innominate artery or brachiocephalic itself is divided into right subclavian and right carotid artery. So, in the arch, in most cases we have this anatomy. In most cases, this is not a rule of thumb. We have this anatomy. Coming into the body, releases oxygen and nutrients. So we have arteries. We have central arteries and peripheral arteries. Aorta is a central artery. In the wall of the central artery, we have three layers. No.
Endothelium,
No.
In the wall of arteries,
Media,
medial,
adventitia.
adventitia, external.
No.
Musculosa.
How many layers do we have?
Three layers.
4 layers.
Three layers.
Three layers.
4 or 3?
It
4
depends,
mucosa, submucosa.
You see, intima,
Yes.
adventitia,
Musculosa.
and media. Media in the middle part, intima in the inner part, and adventitia at the outer layer. See, three layers. Adventitia, media, and intima. Intima is the endothelial part. In the media or media, we have a smooth muscle cells and adventitia. In central arteries like aorta, we have elastin and collagen proteins, which gives the big arteries and elastic properties. They can distend during systole. See, this is a potential energy, and release it during diastole. During systole, they distend and releases this pressure during diastole. That is why the flow in our circulatory system is not continuous. It is a pulsatile flow. We have a pulsatile flow during our circulation. It is pulsatile, it has pulse. It is not continuous current. It has a pulsatile. During systole, they descend and they release during diastole. That is why we can feel the pulse in our arteries. See, this is not the fixed current. For example, in our pipes, in our water pipes, there is a, for example, pump in our water pipe. The fluid flow or movement inside the water parts are continuous. But here in the heart, because they are not distendable, but in our circulatory system, due to the presence of collagen and elastin fibers, they can be distended. They store a potential energy and releasing during relaxation or diastole. This is called, after the name of German physiologist, Windkessel effect. Windkessel effect. A German physiologist. So blood coming into the arteries, arterioles, which in their wall, in their opening to the tissue, there are muscular muscles, especially muscular muscles, which can control the amount of blood that is needed for the tissue. The blood coming into the tissue extract nutrients and oxygen and release carbon dioxide and waste materials into the venules. So arterioles, capillaries exchange is actually taken part, is actually occurred in the capillaries, and then all the waste materials and carbon dioxide back into the venules. Venules connected to each other to make small veins. Veins, great veins. You have two great veins. One that collects the carbon dioxide and waste materials in the upper part, which is called superior vena cava. From the lower part, inferior vena cava. Those substances or materials that trap into the interstitial fluid collected into the lymph circulation and back into the general circulation in the chest. See, part of the blood that has been exchanged with the tissue cannot back or return into the general circulation. They will trap into the interstitial fluid. In that case, they will gather into the lymph circulation. Lymph circulation can collect these material back to the general circulation in the chest. So, inferior vena cava gathers the venous blood from the lower part of the body. Superior vena cava
From the upper part.
And both of them is connected into right atrium.
right atrium, superior vena cava, inferior vena cava, coming into the right atrium, then back to the right ventricle, pump into the pulmonary artery, which carry.
There is a coronary artery from heart.
Coronary sinus.
Also, like the blood in the right atrium with the
Coronary
vena
sinus?
and superior vena.
No, I will discuss that part later.
Mm.
Let me make it simple up to here. So from the upper part, superior vena cava. From the lower part,
What
inferior
about
vena cava.
the heart?
What about the heart? The heart is actually nourished with coronary arteries.
Yeah, I mean this.
The coronary arteries I will discuss. And when the nutrients and oxygen are exchanged in the heart tissue itself,
Yeah.
the venous blood coming back into the ventricle via a special veins that is called Thebesian veins. Thebesian veins. You see, they are not returning to the general circulation. We have two exceptions in our body. One is the lung and the other is the heart. All other tissues will bring back their waste material into the general circulation except that the lungs and the heart. In the heart, the venous blood is coming back into the left and right ventricle via a special venous system that is called the Bayesian
Left
system.
and right ventricle.
Both, yeah. The
How
Bayesian.
can we like this not oxygenated blood, it's going to go like around into the aorta.
Pardon, what is the question?
You say that it's returned to both ventricle
Right side to the right side, left side to the left. For example, the right ventricle needs a special circulation. When they extract oxygen and nutrients and add carbon dioxide to the blood, then the blood should be added into the right ventricle. At the same time, you have the same scenario in the left ventricle. These veins that carry the non-oxygenated blood to the heart is called the Bayesian. This is especially shunt. This is called cardiac shunt, yes.
In anatomy, they told us that in the right atrium there are openings directly into the atrium for the return blood from the heart. So this is what's
No, you're talking about the heart itself.
yes, and they're saying that the blood that goes, for the heart to supply the heart, there are openings inside the atrium for it, other than the vena cava. So these openings, they are the Bayesian.
I'm talking about the ventricle, not the atrium. The right ventricle itself, taking blood, adding carbon dioxide, and then they will empty into the right ventricle
Oh,
via
okay.
the Bayesian vein.
Just so the non-oxygenated blood going to go just to in this circulation, in this exception, going to go just to the right ventricle.
No,
Right.
we have also the same scenario in left ventricle.
What non-oxygenated blood? How we gonna go to the right ventricle?
In the right ventricle, this is the same scenario. Non-oxygenated coming from all the circulation to the right side. Right atrium, right ventricle. Back into the lungs. Oxygenated coming into the left atrium, left ventricle. So, pulmonary artery, non-oxygenated blood coming into the lungs. Oxygenated back to the left atrium via four veins, which is called
Pulmonary.
veins. They are veins but carry oxygenated blood. Pulmonary artery is artery but carry deoxygenated or non-oxygenated. Question. This is general and pulmonary circulation. Now take a look at the coronary arteries, which provide the nutrients and oxygen to the heart itself. See, for each lung we have two pulmonary arteries. Take a look. Pulmonary artery. 1, 2. Going into the lung. Take a look at the. This is. I want to show the aortic valve.
It's also
See, this is the mitral valve, tricuspid valve. This is the aortic valve. How many cusps does it have?
Three.
Three cusps. Take a look.
Another question. The most of heart, the cardiac valves is the tricuspid valve, right?
What is your question?
We have the three tricuspid valves,
Uh-huh.
right? So why is it called-
Atrioventricular valve on the right side is called tricuspid because in most cases, aortic valve does have three leaflets, but in some rare cases we have two leaflet cusps. Two leaflet valve for the aorta. That is why the right side is called tricuspid. Semilunar valves, as you can see, pulmonary and aortic valve is also does have three leaflets or cusps. See, this is a misnomer. You see, this is a misnomer. See, at the base of the aortic valve, there is a bulging area which is called coronary sinus. The arteries that nourish the heart itself originated from that coronary sinus. From the coronary sinus, two big arteries are branching off. One is called left main coronary artery. Left main coronary artery. And the other one is called right coronary artery. So the leaflets are called, these two leaflets are called coronary cusps, and this one is called non-coronary cusps. Non-coronary cusp. So left main coronary artery, right coronary artery. Did you get it?
Yes.
Left main and right coronary artery. Left main coronary artery, after branching off from this coronary sinus, is divided into two branches, two big branches. One is left circumflex artery, and the other one which circles around the groove between the atria and the ventricle. There is a groove between atria and ventricle.
For the coronary.
Interventricular groove. Sorry, interatrioventricular groove. Circles around this groove. And this is called left circumflex artery. The other one, which is branching off from the left main coronary artery, is called left anterior descending in the interventricular groove. Right coronary artery, which is branching off directly from the coronary sinus, is divided into, see, as you can see the heart, when you open the sternum, what you see is the right ventricle and right atrium. Left ventricle and left atrium is actually located in the posterior part, in the interventricular groove. The right coronary artery is divided into posterior descending artery or PDA. In the anterior groove, we have left anterior descending. So we have left anterior descending, right coronary, and circumflex. In the angiography report, you can see if this system is blocked. If the RCA is blocked, it is called one vessel. If RCA and left anterior descending is blocked, it is called two vessel. If RCA, circumflex, and P and LAD is blocked, it is called three vessel coronary artery disease. One vessel, two vessel, three vessel.
Is it the main circulation?
So, how many branches do we have? Three. Right RCA, right coronary artery, left anterior descending, and left circumflex. In most cases, what I said up to here, posterior descending artery, listen, posterior descending artery is branching off from the right coronary artery. In 90% of the cases, posterior descending is branching off from the RCA. In 10% cases, the posterior descending artery is branching off from left circumflex. Left circumflex. That is in coronary artery report. You can see that. This case is right dominant or left dominant. In 90% of cases, posterior descending artery is branching off, is originated from right coronary artery. And in only 10%, PDA or posterior descending artery is branching off from left circumflex. These arteries, listen, these arteries make another branches from the LAD, left anterior descending. You have diagonal arteries. Diagonal. From one point to the other point, diagonally moves. From the left anterior descending. From left circumflex artery, we have branches to the obtuse margin of the left ventricle, which are called OM. Obtuse, OM or obtuse margins from left circumflex artery. So diagonal arteries are branching off LAD, left anterior descending, and OM arteries, obtuse marginal. We have two margins. In the left ventricle, we have obtuse margin. In the right ventricle, we have acute margin. Obtuse margin, acute margin.
The acute margin in the right circumflex?
To the right, no, to the right ventricle. Acute margin is actually seen in right ventricle. Obtuse margin in the left ventricle. Obtuse marginal arteries are branching off from left circumflex artery. Diagonal arteries from left anterior descending. RCA or right coronary arteries in 90% branching off posterior descending and posterolateral ventricle branch or PLV. Posterolateral ventricle branch. So in 90% cases, SA node, AV node, and the conducting system are mostly nourished by the RCA. By RCA. In 10%, they may be nourished by left circumflex artery. Any question? This is not part of your physiology class. I just explain it to you for more information. Now, any question up to here?
No.
No.
Doctor, the 90% AV node and SA node nourishment, the 90% by what?
10%
By
of
left.
left circumflex artery. Because in 10% cases, posterior descending artery is provided by the left circumflex.
No, I'm talking about
But
the 90%.
in most cases, SA node, AV node, I mean the conductive system in the atria are actually nourishing by the right coronary artery. That is why right coronary artery blockade is mostly coincided with cardiac dysrhythmia, because SA node and AV node cannot supply with good oxygenated blood. Keep in mind. Now let us start with